All right, welcome in everybody. Oops, I still have this sound going off. Let me fix this. Okay, welcome. We're going to be continuing with our discussion on factoring. So remember, when we finish factoring, oops, went too far, we will have an exam. So we're sort of here, factoring trinomials, but that section takes more time than you would think to get through that. So we'll see how far we get through it today. So remind me in case I forget at the end of class, like someone just throw it into chat, and probably by then we can figure out exactly when the test is going to be. It's at least a week out, probably more like a week and a half out, maybe 2 weeks, depending on how far we get today. But if you ask before class ends, I can put up there for you. Zoom freeze? I can put it up for you on the sorry, looks like I'm having a technical difficulty here. Let me figure this out a second. Can anyone in Zoom confirm that it's still working or it froze? Mine kind of froze up. I don't know if I'm going to have to start the whole meeting or what's going on. But mine is frozen. Can anyone, let me see if I can put something in chat. Is anyone else in the Zoom meeting able to use chat? Oh, okay. Audio is fine, but the cameras are frozen. Okay. Thanks. That's helpful. So let's see. We have a choice here. What should I do? We just started. Why don't I? Okay, so if you can hear me then, since it sounds like everyone in Zoom can hear me, I'm going to close the meeting down and start a new Zoom meeting. So you're going to get kicked out. Just give me like, whatever, 30, 60 seconds or something to try to restart the Zoom meeting. And then you can try to get back in. So don't go anywhere. Don't leave. Okay. All right, if anyone's watching, you can try to come back into Zoom. Here we go. Looks like people are coming back in. Okay, it looks like the video's working. People are coming in. Okay, great. Okay, so those few people that were in there can come back in as they wish. So we're right here. We have factoring trinomials, which we have to go over. And then we're going to go over special factoring, which is there's a few types of factoring problems that are there. They almost have like formulas. Well, they do have formulas. But one of them is the formula is so simple, people don't even really think of it as a formula, difference of squares. Like most of you will just kind of learn it instantly. It's pretty straightforward. Then there's difference in sum of cubes. Those involve formulas, and you do have to remember the formulas because they can get a little bit confusing. Whoop, it's still chiming each time someone enters. Let me fix that. There we go. Okay. I think we're about back to where we were. Should be good to go. Oh, it's not muting people. Let's see. Let's do it this way. Okay. Okay, so so some people just came in. Today we're looking at factoring trinomials, which the easy trinomials are like the easiest things to factor in the whole chapter. The hard trinomials are like the hardest things to factor in the whole chapter. So you could argue that factoring trinomials is both the easiest topic in the chapter and the hardest topic in the chapter. Just depends on which kind of problem you get. So we have to work through those. Then we'll get to special factoring next. Well, I doubt we'll get to it today. We'll talk about that, and then factoring strategy and solving, and then we'll look at getting ready for the test. So I'll hopefully at the end of today I can give you an estimate of when the test is going to be. If not, then definitely after class on Wednesday I can tell you what the test date is going to be. But it's coming up. Make sure you're getting caught up on the homework so that you can do well on that test. There'll be a written portion. There'll be an online portion. Remember, I'm going to give you practice exams for both of those, so that, it's not a surprise. It shouldn't be a surprise anyways. Like, we have a chapter on factoring, so guess what? You're going to have to factor a few different types of problems. We have a chapter on systems of equations. You're going to have to solve a few different systems of equations, right? So it's I'm not going to throw surprises at you. There'll be problems that you have seen before. But make sure you've done that work so that you can do well on the test and then do well in the class, right? Okay, so with that said, let's get into it. So you have a whole little section here. Oops, let's move this over. Factoring trinomials. So there's different types. There's the factor trinomials where your a is equal to 1. What does that mean? When we talk about a being equal to 1 in a trinomial. So let's remember, a trinomial is, let's start here. A trinomial is a 3-term polynomial. These are the trinomials that you will be factoring the most. Probably once you get out of this section and you're just in like normal math class. So for the rest of this semester, starting with the next chapter, and then in your college algebra or pre-calc or trig or whatever, probably 90% of the problems that you have to factor are going to involve trinomials. So this is the one that you're going to see the most. The other ones come up frequently enough that you need to know how to do them, but like most of the time it's going to be trinomials, right? 80-90% of the time it's going to be trinomials. So what does that mean? That would be something like the following. Let's see. X squared plus 7x plus 12. All right, so that's a trinomial. I think that's big enough. Yeah. So that's a trinomial. Okay. Just 3 terms. Usually it's going to be x squared, x, and then a constant, but not always, right? We can play around and do some different things. So this is what we're talking about today. The general form of this looks like the following. So if we were going to generalize, what are all the different ways that things can be a trinomial? It looks like this is the common way we write it. Ax squared plus bx plus c. Where the a is the coefficient on your x squared, the b is the coefficient on your x, and the c is your constant. Okay, so in this case, we would say that a is equal to 1, b is equal to 7, and c is equal to 12. So it's very common, you'll hear people talk about trinomials where a is equal to 1, even though like here, they're saying a equals 1, but you're like, what's a? I don't understand what it's talking about. When we're talking about trinomials, it's understood that a is the coefficient on x squared. These are the easy problems. Now, when I say that, you might be looking at it now and going, I don't know how to do that. It's totally fine. We haven't learned it yet. But once you go home and you do a few of these on the homework, people are very comfortable with these, right? Very rarely do people miss these kinds of problems on the test. But when we start getting into a being 2, 3, 5, or even worse, when it's things that has lots of factors like 8, 10, 12, that's where it gets complicated, right? When all of a sudden we have lots of factor combinations. So we're going to start off with the easy version of the trinomials today. And then later in class, we'll get into the harder version. And again, when I'm saying easy, don't beat yourself up if you don't know how to do it now, but you will shortly, right? Many of you will kind of understand it by the time we're done with class. So let's remind ourselves what exactly is going on here with these polynomials. So I'm going to cheat here and give us the factored form so that I can give an explanation as to what's going on. Oops, I'm doing it. Yeah, this is the way I want to do it. x plus 4, x plus 3. So right above the polynomial, you see the factored form. So kind of go back to earlier in the chapter. Remember, we spent some time talking about polynomial multiplication. And now we're turning the polynomial multiplication around, and we're sort of unmultiplying. We are factoring, right? So remember what we did? We'd do FOIL here, right? X times x is x squared. For the outer, we'd get a 3x, and for the inner, we'd get a 4x. 3x plus 4x is 7x, giving us this. And then the L part of our FOIL, 4 times 3 is 12. Okay, so again, that doesn't explain how I got this, but I'm just showing you, remember, this is the idea, is not that long ago, I don't know, a week ago or a week and a half ago, you were taking things like this as a product and multiplying them out to be a sum or difference. Now we're working backwards, giving something like this, standard form polynomial. Can I work backwards and put it into product form where it's a product? That's what we're working at, is starting with something in this third line and turning it into something in the second line. Now, what we're basically going to do here is we're going to reverse engineer factoring. And as we do that, we're going to pick up some clues. We're kind of like playing detective here. We like, that's how you can think of it in these, which I know is kind of silly, but that's really what we're doing. We're going to be looking for clues inside of the polynomial that are going to give us hints about how we should factor the thing, because there's just a lot of choices, right? If you just sort of try to brute force it, which means you just try every single possible combination, it's going to take a very long time. If you're clever and you learn how to look for the little clues, like you learn how to be a little polynomial detective, you can reduce those possibilities down to 2 or 1, right? To the point where some of you will get very good, where you look at the polynomial and you're kind of thinking through the clues in your head. And you're looking at the signs in the polynomial, and you're looking at the numbers, and you're going, oh, I think I know how that factors. So some of you will get to the point where you can factor the easy ones in your head. That's great. If you're not someone who can factor them in your head, don't worry about it. You don't need to ever factor them in your head. In fact, I'm the one always telling students to write more down on a piece of paper. In fact, even if you think you're doing it in your head, that's fine. Double check it on a piece of paper, because believe me, it's very, like I do this from time to time, because I teach this, so I'm pretty good at factoring stuff. But even sometimes I'll do one in my head and look at it, and then it ends up being really, really close, but not quite right. I have a sign off or something like that. So, you know, in general, when I do one of those factorings in my head, I still try to write it down and double check it, because it's very easy to make a mistake when you're doing it in your head, and that one mistake makes the whole problem wrong, right? Like if you think about the homework you're doing, the homework, like when Delta Math is grading it, it's not like, oh, real close, we'll give you some points. It's like you had one sign wrong. You just lost a point in that score, right? And you got to work your way back. So I highly recommend you double check it. You do that by just multiplying it out, right? Take your factored form and multiply it out. All right. Now, let's start talking about those clues that we're going to look for in the original polynomial. So I'm gonna switch these around, because I want to talk about it. We're now doing it in the different order, where I kind of had it in the order where we multiplied and then had the factored form. This is how things are going to look from here on out. You're going to start with, in fact, let's even give ourselves a little bit more room here. We are going to start with a standard form polynomial, and we want to turn it into the factored form. Now, students resist me on this, and yet when I really push on them to follow my directions, then they do great. But there's a lot of students that, like, you don't want to write things down, right? And they're like, no, it's in my head, I get it. But then when I say, okay, write the next step, write the next step, write the next, all of a sudden they're done. But what happens is people try to do this whole problem in their head. Now, like I said, some of you are going to figure out that the easy ones you can do in your head. But if you get to a point where you can't do a problem or you're having trouble with it, just stop trying to do it in your head, right? That's like the easiest way around. And I see it all the time with students where they'll sit there for 10 minutes staring at it, trying to do the problem in their head. And then when I tell them, like, Okay, start writing down the steps. They're done in like 20 seconds. So yeah, if you can do them in your head, fine. If you're struggling, just do yourself a favor, put your pencil to the paper and write some stuff down. Even sometimes if you get it wrong, what'll happen sometimes is you'll go, I think it's this, and then you check it and go, no, it's wrong, but it's really close. So then you know, oh, if I just change this sign or I change this one number or something, I'll have it. And then you're there. That's still faster than staring at the thing for 10 minutes and then still not getting it, right? So literally write down every little thing you know. For starting with, let me write this in between here so you can kind of see it become the final form. And students think I'm being silly about this, and I see resistance, but literally I see it work in the classroom. If you're a little stumped at the beginning, literally just write the parentheses, right? If all you can do at the beginning is write the parentheses, write them. Now, when you write the parentheses on your paper, leave a little more room. The software I'm using, since there's nothing in the parentheses, it just puts them together. But I'm going to fill them in. So you should write the parentheses kind of spaced out. Like give yourself some room to put stuff in the parentheses. And I know students go, that's silly. You just want me to write the parentheses? But I'm telling you, every little bit you put on the paper, it frees up your brain to now try to figure out the part you don't know. Right? So literally write every single piece you know. Okay, I'm starting with parentheses. Okay. Well, this is there's a couple of reasons why when we do these problems where the coefficient on the x squared is easier, there's like two main ways. One is right here out of the gate. If your front term is x squared, remember that's the f part of our FOIL. This came from multiplying the first part of the first factor times the first part of the second factor. Well, there's only one way that x squared is going to break down, right? And that's x times x. That's one reason that these are a lot easier. So I know that in here I'm going to have an x and I'm going to have another x. Again, you should leave yourself a little more room in those parentheses than I'm doing because the software is sort of making them as big as they need to be here. So we've got our x and our x. Okay, that didn't take any thinking. That didn't really take any figuring out other than just recognizing my lead term is x squared. So this is going to be an x and this is going to be an x. Okay, now is where it starts to get a little bit trickier, but not too bad. It's one of those things where it seems weird at first. Once you've done them a few times, you're going to be fine. Okay. So let's remember that when I multiply two numbers together, if I multiply two numbers that have the same sign, I'm going to end up with what? A positive, right? If I multiply two positives together, I get a positive. If I multiply two negatives together, I get a positive. So this is the part where, we put our detective cap on and we start studying this polynomial and saying, what are the possibilities? Well, notice here, this is this constant part. That's the L part of our FOIL, right? We get that from multiplying the last part of each of these factors together. Well, what are my options? I have a positive number here. I have a plus 12. So that means that my signs down here must be the same. They're either plus plus or they're minus minus. Now, I don't know which. We cheated here by me giving the answer ahead of time so we can see they're plus plus. But it's possible they're minus minus, right? Because we know it's either plus 4 times plus 3. Well, we don't even know that yet because it could be 6 and 2. But we'll get to that in a minute. Anyways, sorry, I'm saying things a little out of order. But what we do know is when we multiplied these together, they needed to make a positive. So it's either x plus and x plus or it's x minus and x minus. So then how do we figure out which one it is? Right? Yep, and someone's got it figured out already in the chat there, so it's doing good. So we look at this symbol right here, and I go, I need a plus plus. Okay, so how do I know whether it's minus minus, or, sorry, we know the signs are the same. So I go over here, my middle term is positive. Well, if this was x minus 4 and x minus 3, then that would give me a negative 7x in the middle, right? Not a positive 7x. So it must be the case that this is x plus something and x plus something. Okay, see how we're kind of building to the thing below it? Okay, so by looking at these signs here, that gave me a clue as to what my signs down here were going to be. Okay. Now, how do we figure out which numbers go in here? How do I know it's 4 and 3? There's not a 4 and 3 in the original problem. And as is being pointed out in chat, if you think about where these numbers came from, this was the L part. So what did we do? We multiply these numbers to get this, right? You just go through the L part of your FOIL. You multiply these last places to get your 12. So we want numbers that multiply to 12. Well, that can be 4 and 3. That can be 6 and 2. That can be 12 and 1, right? Those are the different ways to break down 12. 6 and 2, 12 and 1, 4 and 3. I wonder which one it is. Well, think about your middle term. Where does the middle term come from? It comes from adding these outer terms with the inner terms. Well, our outer term is 3x, and our inner term is 4x. So when I add those together, I get 7x. So we can see from working through that the numbers that we fill in here need to multiply to the 12, and they need to add to the 7. So let's go through those possibilities. Let's see. 12 and the 3 possibilities that we already know multiply to 12. Well, with 12 and 1, I can't add those to get a 7. So that one's out. Excuse me. 6 and 2 6 and 2 I can't add to get a 7. So that one's out. 4 and 3, can I add to get a 7? Oh yeah. That one works. So that's our value, 4 and 3. All right, and that's how we go step by step to get the actual answer. And remember, if your factors are in the different order, if you got x plus 3 times x plus 4, that's the same answer. It's the same thing, right? It's like 4 times 5 is the same as 5 times 4. It still represents the same thing, okay? So that's half the battle when you're doing these trinomials, is looking at the signs and trying to use that to help you figure out what goes down here inside your factored form. If you can do that, you're going to save yourself a ton of time. You'll move through these really fast. So let's do another one. All right, so I've got x squared minus x minus 20. Okay, so how am I going to work my way through this? Well, and here's a topic I want to bring up again, because I think a lot of times this gets missed when we're going over the factoring. Not every polynomial is factorable. In fact, most polynomials are not factorable, but the ones we're going to give you to factor usually are factorable. Occasionally, you'll get thrown one just so that you remember that there's things called primes, right? And there's a reason we call them primes. It's because they can't be factored, okay? But, you know, if I give you a homework that involves a bunch of factoring, most of them are going to be factorable, because otherwise it's kind of silly, right? Same on a test. I wouldn't give you something on a test and say factor this and it wasn't factorable. What would be the point? That would be a terrible test question, right? So just keep in mind, not all problems are factorable, just like numbers aren't factorable. Remember I showed you how when we factor these polynomials, we're really doing like the breakdown that you did in pre-algebra for breaking down numbers. You do like your factor tree where you take 12 and you'd break it down into 2 times 2 times 3. That's really what we're doing here. We're breaking it down into those factors. And what do we have with numbers? We have numbers that can't be broken down. Like 19 is a prime. Can't break it down into smaller factors. Same thing here. You have polynomials that cannot be broken down into smaller factors. We call them prime. Okay. So just be aware of that. Anyways, for this problem, I know I need parentheses. I'm going to write them down. Okay. Looking at my first term there, my leading term, that's x squared. So I know this is going to be an x and an x for my leading parts of the factors. Okay. Now I put my detective hat on and I go, okay, let's look at these signs here. What do I see? I'm seeing that when I do the L part of my FOIL, I get a negative number. So what is the only way that I can multiply two numbers together and get a negative number? Well, that's if one is positive and one is negative, right? So that means, oh, I must know then that it's going to be x plus something, x minus something. They have to have opposite signs in the factored form, because when I multiply the things that are in this last place, it gives me a negative 20. Well, then they must be different from each other. Okay. All right. So then I'm going, all right, let's play the game we did up here. I want things that multiply to negative 20 and add to negative 1. So what are the different ways I can break down 20? 20 and 1, 10 and 2, 4 and 5. Let's see, that should be it, right? Yeah. Well, if they multiply to negative 20, then one's positive and one's negative. Can I get a negative 1x from those? Well, not with 20 and 1. I'm not getting a negative 1. Not with 10 and 2. Oh, but what about 5 and 4? Yeah, 5 and 4 will work. Okay, so we got to put them in the right place. I want to end up with a negative 1. So if I end up with a negative middle term, that means the negative down here needs to go on the bigger term. So this is where the 5 should go, and this is where the 4 should go. And then we can double check it by multiplying everything out and seeing if I'm right? Because again, sometimes I walk through these and then, when I check it, I go, oh, I did that in my head. I messed it up. So let's see. I'd get an x squared minus 5x plus 4x minus 20. And sure enough, when I simplify that, yeah, it's going to end up being this thing at the top. So that worked. Okay. And feel free to ask questions in chat or otherwise. If anyone has any questions, let me know. Okay. So also, if your answer had been written as this, x minus 5 times x plus 4, that is the same thing. That is the same thing. Notice it's the exact same factors as up here, but written in a different order. Both of those would be correct answers. Now, we have to be careful here with the signs. This is, I'll see this sometimes where students will come up to me and they'll be putting something like this in the computer. They'll be putting this one, and again, I just want to make sure everyone understands this one's wrong. This one down here. Students will come up and they'll be like, I know this is right. I know I'm doing it right because it showed me the answer and it matches my answer. I'm putting in the same thing. Why does it keep telling me I'm wrong? Well, if you look closely, this answer right here is not this one right here. It may be written in the same order, but notice how on these the negative is with the 5 and the positive is with the 4. That's backwards of what you have here, where the 4 is with the negative and the 5 is with the positive. If we multiply this wrong one out, notice it doesn't work. That's why, again, best thing to do when it's important that you get it right, check it. Just check it, because we'll see this isn't going to work. I get x squared plus 5x minus 4x minus 20. And yet, when I simplify this, I end up with a plus x in the middle, don't I? Not a negative x. So sometimes it looks close. It's like real close to being right, but if it's wrong, it's wrong. And the computer's not going to go, oh, so close. Let's give it to you anyways. It's just going to say, nope, you didn't get it right. So make sure when the signs are different, you have to get the right number on the right sign. If you don't, it isn't going to work. Okay? Does that make sense? So you have to go through and do that. Okay? Let's see. Let's do another one. Actually, yeah, here we go. Okay, so here's one. Okay, and notice we don't have equations, right? We're factoring. We're just factoring expressions. Okay, so let's see. Let's get this out of here. All right, so I'm looking at this, and I'm going, okay. X squared plus 11x plus 24. All right, I want to factor this. So what am I going to do? I'm going to put some parentheses in there. I know I'm going to need those parentheses. I'm going to put them in there. Okay, and it starts off with an x squared, so I know my only possibility is that these start off with an x. I'm looking at this sign right here. Since it's a plus, that tells me my two signs are the same. They're either plus plus or minus minus. But then we go to this one and it says, well, if they were both minus minus, how could we get plus 11x? We couldn't, right? So it must be x plus x plus. And now I'm asking myself about factors of 24. Some people can do the factors in their head. Some people need to make a list of factors. It doesn't matter, right? If you have to make a list of the factors, it doesn't mean you're not good at this. It just means that you should be writing stuff on the paper, whereas someone else can do it in their head. It doesn't make them smarter. They just sort of have a visualization in their brain that you don't particularly have. It doesn't. There's not a better way to do it, right? So you just look at 24 and go, okay, what is it we're trying to do? We want things that multiply to 24 and add to 11. So don't necessarily try to do those things at the same time. I see people look at it and go, man, it has to multiply to 24 and add to 11. Just think about the factors of 24 first. And then when you go through that list, then you can decide which one adds to 11, right? That's easier to do. If you're trying to do two things at once, it's generally significantly harder than trying to do one thing and then do the other. So 24 has a lot of factors. So a lot of ways we could break this down. 24 and 1, 12 and 2. 8 and 3, 6 and 4. I think I said all of them. So then you go through those and you figure out the ones that can get you an 11. 24 and 1, no, that's not getting us an 11. 12 and 2, ooh, close, but not quite. Okay, 6 and 4, no, again, close, but close doesn't work in factoring. It's like you go, well, it's pretty close, doesn't that work? No, when you multiply it out, it won't work. 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. There we go. Jackpot, right? And there's our factored form. If we multiply it out, we'll get this back, and we're good to go. We go, great. Great, we just factored that, right? That's really all there is to these. So like I say, people pick these up pretty quick. All right, so if there's no questions, let's move to where things start to get a little bit more complicated, which is where the coefficient on your x squared is not just a 1. It's not just x squared. It's like 2x squared, 3x squared, 5x squared. In those cases, it's actually still not too bad because 2, 3, and 5 are all prime. So it's not that much harder because you only have one way to break down 5, right? It's 5 times 1. What gets tricky is when you have a 12x squared out front and you don't know if you should break it down as 12x and x, 6x and 2x, 4x and 3x. Then all of a sudden you start to have a lot of possibilities, and that can get kind of overwhelming. So we're going to look at a couple different ways to do this. I don't know if I'm going to get through both of them in 15 minutes. I suspect it will spill over to next time, but I'll show you how you can go through and do this. Okay, so let's take a look. Okay, so this one is sort of a medium problem where it's not as easy as the ones we just did, but it's not as hard as the hardest ones that you're going to run across, okay? So here's what we're looking at. We don't get to play that game anymore where we say what multiplies to 2 and adds to 7. Because if we tried to do that, we'd go, nothing's going to multiply to 2 and add to 7, not like over integers anyways. So it doesn't work. we now have a more complicated game to play. So I sometimes see students confuse how to do the simple polynomials with how to do the complicated polynomials. So just sort of separate them in your brain right now. Everything we did previously takes one procedure. The procedure we're going to have to use for these, where the coefficient on x squared is not a 1, it's a different procedure that we're going to go through. In fact, we'll end up seeing a couple procedures. You go with the one that feels most natural to you. Okay, so, well, we need parentheses. Okay, great. Now, this is what I was talking about, where breaking down 5x squared is still not very hard. It's not, this problem will not be as easy as the last ones we did, but 5x squared has to be 5x and x, because 5 is a prime number. There's only one way you're going to break it down over the integers. That is 5x times x, right? When we factor over integers, so we're not getting like 2.5x and 2x, right? It doesn't break down that way. It has to be integers. So since 5's prime, it's going to be a 5x and an x. Okay, so let me get those in there. All right, looking at our signs. What are the signs going to be in our factored form? Well, this plus and back tells me the signs have to be the same. And this tells me that if they're the same, they have to be a plus. Okay, so 5x plus and x plus. Okay, that's not too bad. We're getting there. But how do I figure out the numbers to fill in? And here's where it's a little bit trickier, even though this front part was easy, we have to fill this in. Now, 2 is prime, so that's nice because we know that 2 has to break down as 2 times 1. So you go, oh, well, that's simple. We're done, right? No, because I don't know if the 2 goes here in this first factor or in the second one. It makes a difference because before we just had an x in the front of both of them. So it'd be like x plus and x plus. But here, if I put the 2 in the wrong one, it's not going to work right anymore. So I have to figure out, does a 2 go here or does a 2 go here? Well, if you're not sure, one thing you can do is called the guess and check method, which is where now that we've eliminated our possibilities down to just basically 2, there's only 2 possibilities left. Either the 2's in the first factor or the 2's in the second factor. So which one's it going to be? Well, just try one, right? So, some of you will get to the point where you're good enough with this that you can start to see where the 2 should go, but that only comes with lots of practice. That comes with doing these problems a bunch of times, and then you'll get better at sort of seeing inside the polynomial and seeing what the combinations are going to be. But out of the gate, you just try one. So let's see. Here's my guess. I'm going to guess that I'm going to put the 2 here and the 1 here. And I actually don't know off the top of my head. It's a little distracting when you're explaining while you're doing it. You can't view in there as much. So, but let's just see. So I'm going to multiply this out. 5x squared plus 5x plus 2x plus 2. Looks like that's the 1. Right? Because when I add these two together, I get 7x in the middle, which is the right answer. Okay, great. We're good. Okay. Notice that if I got it, let me leave a space here, and then we're going to do it the wrong way. Wrong way. Notice that if I had guessed wrong, here's what would happen. We would have had what? 5x plus 1 and x plus 2. That was the other possibility, right? Well, what happens when I multiply that out? I'm going to get 5x squared plus 10x plus x plus 2. Well, when I add my 10x and my x, I'm going to get 11x, but we're supposed to get 7x. So I know this one's wrong. Even though it looks right when you look at it, you're like, isn't that the same? Oh no, the 2's in the different spot. If you have anything in the different spot, it makes a big difference. So you have to make sure these combinations go together properly. Okay. And having prime numbers in here really simplifies this problem, right? I said this one was going to be hard, but we moved through it pretty quickly. That's because we had a prime on the front and back. Once you lose that, it gets a little trickier. Let's see what they're doing over here. Let's jump over to here and do a couple of these. So let's see how this would work. All right, so let's break this down. I'm going to need parentheses. I'm going to have an x and an x. Ooh, okay, so I have a minus here. So that means that this is going to go plus, minus. Okay. So I want things that multiply to negative 28 and add to 3. So let's see. What are the ways I can make 28? 28 and 1, 14 and 2, 7 and 4. Ooh, 7 and 4 might be the one, right? Let's see. Is there any other factors that go in there? I don't think so. Okay, so it looks like with 7 and 4, we can get a 3, but I have to make sure I put the plus on the right one. I want a plus 3. So when I add the outer to the inner, we need to end up with a positive number, meaning the positive needs to be the bigger value. Okay, so that means this one's going to be 7, and this one's going to be 4. Let me just see here. Before I hit submit answer, I might as well just check it, so that I don't lose my point up here. I mean, I can't get any lower than 0, but you know what I mean. You're about to move on to the next topic, and then you miss one, and you're like, I got to do 2 more of these things. So let's see. X squared minus 4x plus 7x minus 28. Submit. There we go. Looks like the rendering is a little messed up here. Oh, it didn't give me the same one. I want to show you that how it does that. So I want to get back to the solution here. I guess I can see the solution if I want, but we'll just get, what's this going to be, 8 and 6? Hopefully that renders right this time. Nope, it's rendering incorrectly for some reason. I don't know why this is coming out messed up. Is that a Firefox thing or a Delta Math thing? I don't remember seeing that before. This is called, some of you may have seen this before, they call this the big X method. It's like a big X on your paper, right? I've never really seen the point of it, but some students love it. To me, I don't understand how writing the X on the paper makes the problem any easier, but if it makes it easier for you, then you should do it, okay? Don't be ashamed. It's not like, doesn't mean that you don't know math or that you can't do it. Whatever organization works for you to get the problem finished, just use it. Right? At the end of the day, we only care about you getting the problem right. So here's what happens. You've got x squared plus 14x plus 48. So to factor that, we ask ourselves what 2 numbers multiply to 48 and add to 14. So what you do is you just write those numbers here, 48 and 14, and then on the side you write the factors, but you can't see it right because it's not rendering right. But if you look up, I don't want to search it now because when you're live and you search for something, you never know what's weird things are going to pop up. But if you just Google the big X factoring, you can find a video where they tell you exactly how to do it that way. So if you think writing a big X on the paper is going to help you figure out what multiplies to 48 and adds to 14, by all means, you should do it. Okay. To me, it's like, the way I've been doing it here, we're asking the same question, right? When we do it, I'm asking like, well, what multiplies to 24 and adds to 11? Here you're doing the same thing, but with an X on your page. It just seems to take up more room. But if it works for you, do it. Seriously. Okay, there's nothing wrong with you if you use this X method. There are millions of high school students right now around the country drawing big X's on their paper to help them factor the thing. So don't worry about it. Okay? If you're embarrassed or something to write the big X, it's fine. Okay. Let's go to the next problem. And then you sort of keep doing that. So this one would be what? X minus 5, X plus 1. Submit. Get our answer. There we go. Yeah, it keeps rendering in really kind of a lousy way, but that's how it looks. Okay, let's go back. Let's look at just Just a minute left. Let's look at one of these. We'll spend a little bit more time going over these ones where the lead coefficient is not a 1. I'll show you next time how to do it with factor by grouping. Some students really look like that. I actually do that when I have a problem where I look at it and go, there's a lot of possibilities for this one. I usually switch over to factor by grouping. I'll show you that next time. But here, we're going to play that same game. Luckily, the one in front is prime, so we know that has to break down as 3x and x, right? There's no other way we're going to get a 3x squared because it's prime. But notice the number in back's not prime now. The one that I showed you a minute ago, both terms, the lead and the following term, the one in back, were primes. That made that problem a lot easier. But here this one's harder because with 12, we're like, well, 12 could be 12 and 1, 6 and 2, 4 and 3. I don't know what's the right one to use. And it's not just which ones add up to 20 now because this 3 factor messes it up because when we do the outer number gets multiplied by 3. So this is where, like, I can do these a lot of times by looking at them, but that's because, you know, I teach these courses. So I do hundreds of these problems a year, whereas, you know, most people don't do hundreds of these problems a year. So you just try different factors, right? So that's what they call the guess and check method. Just start sticking stuff in there and see if it works. We do know that our signs are going to be plus and plus, right? If you don't understand why it's plus and plus, go ahead and ask, and I can explain that again. So let's see. If I put a 4 and 3, 3 and 4. Nope, 6 and, oh, it's a 6 and a 2. So you might go, how did he know that? Well, basically, because I'm better at these, because I do them all the time. I teach the course, right? That's literally why I show, like I say, I end up doing hundreds of these every year. So I'm pretty fast with them. I'm able to look at them, and I do the guess and check that you just learning these are going to be doing by hand. So basically what you do, you take fill it in as much as I did, like to where we get to this part, right? We didn't have to do anything tricky to get to this part. Once you do, take your best guess at what you think the factors of 12 are going to work in here. So I'm going to put 6 here and 2 here. And just try it, right? It doesn't take that long. I know students get frustrated with guess and check because they're like, oh, I'm on like the 4th or 5th check. Yeah, the hard ones might take you 4 or 5 times before you get it right. But the good news is each time you try one and it doesn't work, you've just reduced the number of possibilities by 1. So you'll get there eventually. And the better you get at these, you'll get there faster because you'll start to say in your head, you're like, well, I think this one's wrong, so I'm not going to try that one. I think this other one's wrong. I'm going to skip that one. I think it might be this one. And the more of these problems you've done, the more often you're going to be right the first or second time, right? So I made, this is my guess. Let's see, I'm pretty sure it's right. There we go, right? So then they kind of break it down here. Notice they're not using that x anymore. The x on the screen that I showed you, they're not using that anymore. Why? Because once you have that coefficient in front of your x squared, it's a different procedure. Don't try to use one procedure for the other, okay? And then we get that final answer. Okay, so that's how that works. So next time we'll look at these, except I'll show you how to use factor by grouping to get these. Some students like that. Some students prefer the guess and check. It's totally up to you. Some students don't like, you know, I find it frustrating when I'm trying to do one and it's taken me like 6 or 7 tries and I'm like, man, I still didn't get it yet. You know, if it's one that has a ton of factors, I find that frustrating. So the factor by grouping method gets around that, but some people don't like the factor by grouping method because it has its own issues that go with that. So I'll show you next time. You're welcome to use whichever method you prefer. Use that one. Okay. All right. With that said, I'm going to shut down the YouTube stream. Anyone who wants to talk to me in Zoom, feel free to do so. Then I'm going to drive to school. I'll have my office hours. So if you want to come see me in office hours, feel free to do that. Otherwise, I will see you in a couple days. If you're behind, now is the time to get caught up, right? You don't want to be getting caught up right before a test. You want to get caught up now so that you're ready to study for that test, get a good grade, and move forward with that, okay? All right, thanks, everybody. We'll see you later.